understand what I'm trying to say. So this is a string, and this is a small mass m. Okay, this is called a small mass m of a bob, and let us say this point is a O, and let us say this is a string of length L. Okay, now you suspend vertically. Okay, you are suspending it vertically. So this is called a simple pendulum. Now let us say you give a small oscillation. Okay, let us say you give a small oscillation to it. Small oscillation means what? Let us give small angular displacement. So how do you give a small angular displacement? Let us see. Okay, so I will erase this out and I will give a small angular displacement. Okay, let us say this is A. Okay, so let us say small angular displacement is given theta in this direction. Okay, so what will happen? This mass m will move from this position to this position, right? So let us say this is the center, this is the center. So it will move from this position to this position, center. Okay, so you have given a small oscillation theta, small angular displacement theta. So theta is nothing but a small angular displacement. Okay. So as I said earlier in the module number 3, I'll be explaining you the mechanics behind this. Okay, a detailed mechanics behind this. Okay, but just here the concept. Okay, so let us say you call this as a mean position. Okay, this is called as a mean position. This is called as an extreme position. Okay, so again let us say after some time from this point again the mass m will move at this point and again it will come to this point. Let us say. Okay, I'm coming at this point. Okay, so let us say this is again a extreme position. Okay, so as I said that at extreme position your potential energy is maximum, and at mean position your kinetic energy is always maximum, right? So your potential energy is maximum, so your kinetic energy will be 0, and your kinetic energy will be 0, and your potential energy will be 0. Now tell me, from this diagram what do you understand about the simple pendulum? Yeah, what will happen in this case? Anybody? If you have understand this mechanics, what will happen? What is simple pendulum? Okay, a small mass which is suspended at the end of the string with a length L. If I give a small angular displacement theta, okay, so what will happen? At the mean position, your kinetic energy is maximum. At the extreme position, your potential energy is maximum. So this mass m will oscillate from this position 1 to 2 and 2 to 3, right? So there is an oscillation of this, you can say the pendulum from the position 1, 2 to 3. So this is called as a vibration, or this is called as an oscillation in case of a simple pendulum. Now tell me, have you understand this or not? Anybody? So this is called as a simple pendulum. Clear? So how I suspended? I have suspended it vertically downwards. Vertically downwards. Very, very important point. So when a small piece of mass m, this mass m is called as a bob. When the bob m is suspended vertically downwards, and you give a small angular displacement theta, it will start oscillating. Then you are giving a small angular displacement theta means what? You are applying some external force, right? You are applying some external force, that is external torque. You are applying some external torque, right? So this external torque you are applying in the form of theta, that is angular displacement, and that is why energy enters inside the system. There is a conversion of energy from kinetic energy to potential energy to you can say again a kinetic energy, and this mass will start oscillating about this point O, and this point O is called as the suspension point. This point O is called the suspension point. Now tell me, have you understand the simple pendulum or not? So I can move to the compound pendulum. Yes? Have you understand this? What is simple pendulum now? Hello? Anybody?
Yes, sir.
Okay. Now compound pendulum. The difference between the compound pendulum and the simple pendulum is the body which you suspend. So in a simple pendulum, you have taken a string connected to the mass m and you suspended it from the point O, and this is the length L of a string. So this was a string in the simple pendulum, and this was a small bob. Here we are taking a rigid body. So if I take an example of a connecting rod, practical connecting rod, okay, so that can be also called as a compound pendulum, right? So first of all, understand, then I will go to the example. So when a rigid body is suspended vertically and it oscillates with a small amplitude, under the action of force of gravity, the body is known as the compound pendulum. Is it clear? So let me take an example. So let us say this is a small rigid body. Okay. If you take an example of a connecting rod, let us say this is a connecting rod. Okay, this is a connecting rod. Okay, so this if you take a small example of a connecting rod and you suspend it at this point O, and it is suspended at this point O, let us say this is O1 and let us say this is O2. Okay, so this connecting rod can be also called as a rigid body or not. So this connecting rod having a mass m, here let us say m1, let us say m2. So this is nothing but a connecting rod. So you take an example of this connecting rod, or you take an example of the simple scale. Simple scale with the holes mounted over, with the holes in perforated over there. So tell me, can connecting rod be called as a rigid body? Yes. If you take a connecting rod and suspend it at the point O, can you call it as a compound pendulum or a rigid body suspended vertically? Hello? Anybody? Yes?
Yes, sir.
Yes, sir. So basically, I am talking about the model number 2, where I am doing the analysis of a slider tank mechanism. So this connecting rod will be at, if you suspend a connecting rod at the point O, which is called the suspension point. This O is called as a C, point of suspension. This connecting rod will also become a, you can also call it as a uh, compound pendulum. So if if I say you do the analysis of a connecting rod by treating it as a compound pendulum, so you have to apply the same theory which I'll be explaining you now. Okay, जे आता मी तुम्हाला सांगणार आहे ती एज एन एक्झाम्पल म्हणजे मी तुम्हाला ते होमवर्क म्हणून देणार आहे. ठीक आहे, कंपाऊंड पेंडुलमला ट्रीट करायचं, सॉरी कनेक्टिंग रॉडला एज अ कंपाऊंड पेंडुलम अँड डू द एनालिसिस फॉर इट. ओके, so chalo. So now here I am not taking a connecting rod. I am just taking a scale because we are going to perform practically also. And in practical case we have a scale. Okay. So let me see that this is a point of suspension. Okay. So point of suspension is there, and let us say this is the H. Okay, H means what? The distance from this, let us say this is a point O and this is a CG. So distance between the point of suspension and the center of gravity of a rigid body is called as H, that is the height. And this is nothing but the mg. Okay, now initially the scale ki position kashi hoti? Initially the scale was like this was the position of the scale. Am I correct? Now you can see that they have given about this point O, they have given a small angular displacement theta, and because of the small angular displacement theta, what will happen? This rigid body is being vertically suspended and it started oscillating about this angle theta, that is about this point O, and the oscillation of this rigid body is called as a vibration. And this rigid body, which is suspended vertically and oscillates with a small amplitude, is called as a compound pendulum. So basically, first of all, you have to do a free body diagram. Now, first of all, message me. Have you understand the concept of compound pendulum or not? Anybody? Have you understand? See, whatever the concept I will be explaining you today in this particular session, this is very, very helpful for you in the next 3 models. That is model number 3, 4, and 5, and 6 also. Okay. So now, before I go and draw the FBD, have you understand this? So this is the FBD. Now this is the free body diagram. Obviously, you might have not understand this how this came, but I'll be explaining you. Okay. But this is how the free body diagram will look. Okay. Let us draw this free body diagram. Okay. I am interested to draw this free body diagram with my own way. Okay. Now, first of all, tell me, have you understand this? What is compound pendulum? Anybody? Yes or no? And what have you understand the difference between the simple pendulum and a compound pendulum? No? Yes, Rajendra, Bhushan, and
Yes,
anyone.
sir.
Is it clear?
Understood.
Okay, yeah. Try to be in touch with me. Okay. Now, how to draw this? You can say free body diagram. So first of all, mark a point O. Very, very important. After marking a point O, let us say that I will consider as a single line. Let us say that this is what you can say a rigid body or the scale or a compound pendulum at an initial position. Okay, let us say this is an initial position. Now, let me say that I have given a small angular displacement theta. Let us say this is a small angular displacement theta given at this point, suspension point. Okay. So I am given small. Okay. Let us say this is the point G. I will change a page. See how I am drawing a free body diagram. Very, very important. You understand. Let us say this is a point G. So G will also move from G to G dash. Is it clear? Do you understand this? Okay. Now let me take another pen and let me draw this. Now this distance from this to this. What is this distance? Anybody? What is this distance? H.
H.
Now this distance is h. Okay, chalo. Now I'll take another pen. Now tell me what I have done. Okay, I have considered the initial position. So from initial position, I have given a small angular displacement theta. So I've got a new position. Okay, so from new position, let us say that now mg. What is mg? Anybody? What is mg? What is
Weight.
mg? Wait, how where it will act? Where it will act? Vertically downward.
Downward.
Down.
Downward position.
Okay. So I am drawing a mg here. Okay. Now tell me how many components this mass will have? Anybody? How many components this mass will have? This mg will have how many
Two.
components? Let
Two.
if this is a theta, this is also theta. Am I correct? So let us say this is a cos component, mg cos theta, right? This is a sine component, mg sine theta. Mg sin theta. Okay. Now, first of all, understand what is the direction of theta. Tell me anybody, what is the direction of theta which I have given? इथपर्यंत जर तुम्हाला समजलं असेल. First of all, tell me, have you understand this diagram? How I have drawn this diagram? You have to solve problem on this first of all, and again you have to do the practical also. Now tell me, have you understand the diagram which I have drawn here? A free body diagram. After giving a, so this diagram is called a dynamic, you can say a dynamic force analysis because it comes under dynamics, no? Because the system will vibrate. The system is under the motion. So under the motion, and then I have drawn a free body diagram. Now, tell me, what is the direction of this theta, clockwise or anti-clockwise? Here, what I have taken. What is the direction of theta? Please speak fast. Hello, anybody? What is the direction of theta in this case? Direction of applied
Anti-clockwise.
displacement. Yeah. So it is not necessary that you should take anti-clockwise. You might have taken a clockwise also. I don't matter. But important point is that you have to just see what is the applied direction. So applied direction is anti-clockwise. So when the direction of the applied displacement, that is a small angular displacement theta, is in the anti-clockwise direction, it is very, very important that theta dot and theta double dot will be also in the direction of the applied displacement. Now, can anybody tell me what is theta dot and theta double dot? Yes, anybody tell me what is theta dot and theta double dot? I have already explained this, but once again. What is theta dot? Hello? Be fast. Hello?
Angular
Angular. And theta double dot? What is theta double dot? Angular? Acceleration. काय झालंय माझा आवाज येत नाहीये का तुम्हाला? Am I not audible to you? Is there any issue? Am I not audible to you? Yes? Hello? Who is Datta Bhushan? Am I not audible?
Yes, sir. Yes, sir. You are audible.
Okay. Chalo. So now the first point you should understand that the theta and the direction of theta dot and theta dot will be the same. Means what? Let us say if you are given the x downward direction, okay? So x dot and x double dot will be also in the direction of applied force. So basically you should understand that the always see you are applying some force now. In which direction you are applying some force in this direction, that is F. Now in this case you are not applying a force. In this case you are applying a torque, right? No? You are applying a torque in terms of theta, right? So direction in which you are applying a torque, the direction in which you are applying a torque will be equal to the direction of the applied displacement. So means what? The direction in which, let us say F is the direction in which you are applying the force. So the direction of the displacement, direction of the velocity and angular velocity or linear velocity and linear acceleration will be always in the direction of the applied displacement. So this is what you have to understand. Okay. So this is theta double dot and theta dot. Okay. Now what we'll do? Now let us apply some principle. So basically, there are a lot of methods which you will be studying in model number 3. Like energy method is there, Newton's method is there, D'Alembert's principle is there. So here I will use some 2 or 3 methods. Okay, I will use some 2 or 3 methods maybe. Sorry, here I will explain you only one method. Okay, now first of all, let us understand what is D'Alembert's principle. Okay, now if you have understood how to draw a diagram, write there by D'Alembert's principle. D'Alembert's principle. What is D'Alembert's principle? D'Alembert's principle says that summation of inertia torque. Now this is a torsional system, right? If it was a linear system, what you would have taken? Inertia force, right? Summation of inertia torque plus external torque. Plus external torque is equal to 0. Now, whenever you are using, guys, the most disadvantage of this D'Alembert principle is that you don't have to take care of the sign conventions. I will also explain you the Newton's principle, Newton's, you can say, method. So there, the sign convention is very, very important. Now tell me what is inertia torque in this? In this case, inertia torque is what? Inertia torque is I into theta double dot. Remember, what is inertia force? Can anybody tell me what is inertia force? M into x double dot is nothing but the inertia force. Mass multiplied by acceleration is called as the inertia force, right? We know this. Similarly, what will be the inertia torque? Mass moment of inertia into angular acceleration. So I into theta is the inertia torque. Okay. So I into theta doesn't no need to take care of the this one. What I mean to say. In D'Alembert's principle, you don't have to take care about the sign convention. Okay. You have to just write what is inertia torque I into theta double dot. Okay. Now, so this I into theta double dot is called as the inertia torque, right? What is this? This I into theta double dot is nothing but the inertia torque. Okay, so this inertia torque is nothing but the I into theta double dot. Okay. Now next is what? When you are trying to apply the torque, म्हणजे जेव्हा तुमच्या सिस्टीमवरती I theta double dot हा टॉर्क अप्लाय होतोय, म्हणजे तुमची सिस्टीम ह्या पोझिशन, लेट अस से A पोझिशन पासून B पोझिशनला गेली. Now there will be a counter torque. There will be a counteracting torque. This counter torque is called as a restoring torque. What is this called as a restoring torque? Now what is this restoring torque? Now restoring torque is also called as the external torque. It is nothing but the external torque which will try to bring your system to the equilibrium position. And this torque will oppose this inertia torque. Very, very important. So always it will act opposite to this inertia torque. Now tell me in this system, if I theta double dot is the inertia torque, what is the restoring torque? Or what is the external torque? Or what is the counteracting torque which will try to bring the system? Or what is a couple? Yes, anybody? Anybody? From the free body diagram, can you tell me what is the restoring torque in this case? Be fast, I have a very limited time. Hello? Anybody? Have you understand? तुम्ही जर लवकर बोललात ना तर आपलं पटापट होईल. वेळ काढू नका. आपल्याकडे वेळ कमी आहे. What is the restoring torque in this case? Hello? Yes. What is the restoring torque? Have you understand or not? Anybody? I theta double dot is the inertia torque, right? Then I am saying that there is a restoring torque or external torque which will act opposite this inertia torque. Now tell me now, which is the torque which is acting opposite to this inertia torque, which will try to bring the system to the A position? Anybody? What is that torque, or what is that, you can say, movement torque म्हणा, काय हवं ते म्हणा. Yes?
I theta dot.
I am asking something. Okay, so what will external torque? Can you see into the figure what will be the external torque? Very easy. Now see, what is the force first of all? This mg sin theta is nothing but the force, right? Now this mg sin theta multiplied by h, right? Now, so mg sin theta multiplied by h. See, this is mg sin theta multiplied by h. How it will act? It will act opposite to this. Right now, असा act होणार आहे, clockwise act होणार आहे. So it will act opposite to this I theta double dot. Am I clear or not? Am I clear? Hello? Have you understand this?
Yes, sir.
Okay, so mg sin theta into h will be what? Your external torque which is acting opposite to the I theta double dot. Okay, so inertia torque and so now I will write here. So what is the inertia torque now? So inertia torque is nothing but the I theta double dot plus, okay, no need of the sign convention here. You have to just understand what is inertia torque. Inertia torque is always equal to the I into theta double dot. Like inertia force is equal to m into x double dot plus external torque means what the torque which is acting or counteracting this inertia torque, or it is also called as a restoring torque. Try to understand. This is also called as a restoring torque. Very important. So what is the restoring torque? Mg sin theta into h, right? So this should be equal to 0. So when this condition is satisfied, you can say that the system will come to its equilibrium position. Okay. Now since आता मी सुरुवातीलाच एक डायलॉग म्हटलाय, वी आर गिविंग अ व्हेरी स्मॉल अँगुलर डिस्प्लेसमेंट. सिन्स थीटा इज very small, since theta is very small, see what is the assumption I am taking. This is nothing but an assumption. Huh? This is nothing but an assumption. So since theta is very small, sin theta equivalent to theta, right? So sin theta will be equivalent to theta. This is the concept of vibration basically which I am explaining you. Okay. So I theta double dot plus mg theta into h is equal to 0. Okay, so what I will get now? Theta double dot plus mg h upon I into theta is equal to 0. Right? So I have got this. Now whatever the equation you have got, this is called as the equation of motion. This is called as the equation of motion, right? Because in compound pendulum, guys, you have a motion. So finally I have derived the equation of motion for it. Okay, now tell me what is the fundamental equation of simple harmonic motion. Now already you have derived in maybe in 12th standard, maybe in first year, second year, fundamental equation of simple harmonic motion. Why I am considering a simple? I am assuming that the compound pendulum is oscillating by a simple harmonic motion. It is a simple harmonic motion. So fundamental equation of simple harmonic motion is theta double dot of m omega n square theta is equal to 0. Now if you compare both the equations, mgh plus I theta theta double dot plus is equal to 0. So comparing both the equations, what you get? You are getting omega n square is equal to what you are getting mgh upon I. So omega n you are getting square root of mgh upon I. And this, what is this omega? This omega n is called as a natural frequency of a compound pendulum. It is called as a natural frequency. So ultimately, from the equation of motion, I have derived a natural frequency. Right? I hope you understand it. Because any system, this is a vibratory system first of all. Why? Because it is oscillating after you are giving a small angular displacement theta. So any system which will vibrate at which will vibrate at some frequency, and the frequency of vibration is called as a natural frequency. Right? This natural frequency is basically a design frequency which you are designing or which you are fixing while you are designing a certain machine. So each and every machine, I will be talking detail in module number 3. जसं मी module number 3 चालू करणार, मी याच्याबद्दल डिटेल आपण बोलणार आहे. ओके, सो नॅचरल ओमेगा इज नथिंग बट अ नॅचरल फ्रिक्वेन्सी. एवढं तुम्ही समजला तरी बस झालं. इज इट क्लिअर? इथपर्यंत क्लिअर झालं तुम्हाला? ओके, नाव नेक्स्ट I. Now next of all, let what is natural frequency? Mgh upon I. First you know what is m, you know about j, you know h. Now tell me, this is a point O. First of all, I have to find out I. How will you find I? Anybody? What is I? I is nothing but a moment of inertia about point O. Can anybody tell me how will you find the moment of inertia about the point O? Moment of inertia of the I point O. What is moment of inertia about the point O? अरे moment of inertia तरी काढता येतो ना तुम्हाला at least. What is the by using a parallel axis theorem? Have you heard this word? Parallel axis theorem. Moment of inertia of a point O, about this point O, that is IO, is equal to what? Anybody? Yes. Okay, how will you find out the moment of inertia, guys? Come on, we have studied this. IO is equal to, by using a parallel axis theorem, Ig plus mh square, mass into distance. See, about this point O, I have to find out the moment of inertia about G, that is center of gravity, plus m into h square. Parallel axis theorem, na? let us say this is one axis, and about the CG we have another axis, right? So now you know that. So I will move forward. So if you want to find a moment of inertia I about point O, it is nothing but the Ig plus m into h square. Now tell me what is moment of an inertia about point Ig? Moment of inertia of a rigid body about point Ig is what? Anybody? Hello? At least tell this one. What is the moment of inertia of a point of a rigid body about the center of gravity? Mk square, na? Equal mk square. So I is nothing but the mk square plus mh square, right? So now what is omega n? Omega n is nothing but the square root of mgh upon I. So I am getting this formula as mgh upon what I am getting? Mk square plus mh square, right? So omega n, finally I am getting square root of will get cancelled, gh upon k square plus h square. Okay. Now consider for simple pendulum. Now I will not go into the derivation of simple pendulum because the derivation for the simple pendulum I will be deriving for module number 3, but it is very very simple. You remember that for simple pendulum omega n is equal to square root of g into l. Now this is, let us say, equation number 1. This is equation number 2. Compare equation number 1 and 2. What you are getting? What you are getting? L E is equal to. See now, if G is cancelled, G is cancelled. What is the remaining point? L. L is the remaining point. This is the L is the remaining term. And what is the remaining term? H into K square plus H square. So you are getting L is equal to K square plus h square upon h, and this L is called as a equivalent length of a simple pendulum. This is called as an equivalent length of a simple pendulum. Now guys, now what is the use of this what is the effect, or you can say what is the use of this length of the simple pendulum? Okay, so this length of the simple pendulum, that is LE, is used to calculate the further natural frequency omega n, or the time period, or maybe the k, or maybe the h, or vice versa, right? So this LE is called as a equivalent length of the simple pendulum, and this equivalent length of the simple pendulum is calculated from this formula k square plus h square upon h. Now tell me, have you understand this or not? Now just tell me, have you understand this derivation or not? Hello? Message me.
Yes, sir.
Have you understand how I have taken all the terms? It's very, very important. Huh? Okay. So I hope you have understand. Shall I explain you again how to draw the free body diagram, or you have understand how to draw this free body diagram? What is inertia torque? What is external torque? What is D'Alembert's principle? Okay. Well, uh, let us say if you want to apply, if you want to apply, in this case Newton's method. Can anybody tell me? I have applied a D'Alembert's principle. जर तुम्हाला न्यूटन मेथडने हे सॉल्व करायला सांगितलं तर तुम्ही कसं केलं असतं या केसमध्ये? Yes, Newton's method. Anybody? Yes. Anybody? न्यूटन मेथडने तुम्ही कसं सॉल्व केलं असतं? Just for your understanding. Okay. Same. If I say apply Newton's method, what you would have to see. मी तुम्हाला न्यूटन मेथड पण दाखवून ठेवतो. Okay. Again same. This is a suspension point O. Okay. Let us say you are moving from A to point B. This is the point O. This is the point, let us say A. Okay. This is a point G. This is a point G dash. Okay. Now let us say this is a mg. Okay. So what will be this? Mg cos theta. What is this? Mg sin theta. Okay. This distance is h. Okay. And this is theta. This is theta. Okay. Now tell me what is, first of all, if I say now I have applied a D'Alembert's principle, मी तुमच्यावरती चॉईस सोडतो. तुम्हाला D'Alembert's principle अप्लाय करायचं आहे का तुम्हाला हे अप्लाय करायचं? Okay. So मला सांगा, what is the statement? What is the statement for Newton's principle? Anybody? What is Newton method first of all? What is Newton method? What is Newton method? Hello? अरे न्यूटन मेथडचं स्टेटमेंट काय आहे बाळांनी? ते कमाल करता तुम्ही. थर्ड इयरला आलायत ना, 2 वर्ष शिकल्यात ना इंजिनिअरिंग. व्हॉट इज न्यूटन मेथड? स्टेटमेंट फॉर न्यूटन मेथड. समेशन ऑफ एफ इज इक्वल टू एम ए, राईट? डी एलिमेंट्स प्रिन्सिपल काय सांगितलं होतं? समेशन ऑफ एक्सटर्नल फोर्सेस, समेशन ऑफ एक्सटर्नल फोर्सेस प्लस इनर्शिया फोर्स इज इक्वल टू 0, राईट? हे त्याचं स्टेटमेंट होतं. कोणाचं? डी एलिमेंट्स प्रिन्सिपलचं. न्यूटन्स मेथडचं स्टेटमेंट काय? समेशन ऑफ एफ इज इक्वल टू एम ए. ओके, म्हणजे ना आता ह्या केसमध्ये तुमचा एफ म्हणजे काय? तुमच्या इथे रिस्टोरिंग टॉर्क आहे, बरोबर? रिस्टोरिंग टॉर्क. आणि एम ए म्हणजे काय? तुमचा थोडक्यात इनर्शिया टॉर्क झाला. ओके, आता मगाशी आपण साइन कन्व्हेन्शन बघितलं होतं. इथे हिअर इट इज व्हेरी इम्पॉर्टंट टू टेक अ साइन कन्व्हेन्शन. लेट अस से, टेल मी, विल टेक एंटी क्लॉकवाइज निगेटिव्ह और क्लॉकवाइज निगेटिव्ह? You tell me. You have to fix some sign convention. What will take? Anti-clockwise positive. Sorry, clockwise positive and anti-clockwise negative. It is okay. Is it okay? Sign convention for Newton method. Why D elements principle is very easy. There we don't have to consider sign convention. But here the sign convention is very easy, important. Okay. So let us say now what is restoring torque? Restoring torque is mg sin theta into F. Tell me, it is acting anti-clockwise or clockwise? Anybody? Mg.
Clockwise.
So it will be positive or negative? Positive.
Positive.
Equal to. Now tell me inertia torque. How is inertia torque acting? This is I theta double dot. Now, theta dot is what? In this direction. So I theta double, this is theta and theta dot. So tell me how this I theta double dot is acting, clockwise or anti-clockwise in this case? Theta double dot चं डायरेक्शन कसं आहे? Hello? अरे थीटा डबल डॉटचं डायरेक्शन
Anti clockwise.
अँटी क्लॉकवाईज. म्हणजे इथे मायनस येणार. आता हे सगळं तुम्ही एका साईडला घ्या. जर मायनस इकडे घेतलं तर तुम्हाला काय मिळालं? आय थीटा डबल डॉट प्लस mg sin theta into h is equal to 0. So you are getting I theta double dot plus mg h theta is equal to 0. Now tell me, have you got the same answer? So from this you will get omega n is equal to square root of mg h upon I. So whether you apply D elements principle or whether you apply Newton method, are you getting the same answer or not? Tell me.